another equation of motion for us to tangle with. They tell us the second derivative of our position, in other words, our acceleration, which is, I haven't done Leibniz notation in a while, so I'll do it here just for variety. Our second derivative is x minus 1. So velocity, which is the first derivative, will be the antiderivative of x minus 1 dx. And so the antiderivative of x is 1/2 x squared. The antiderivative of -1 is negative x, and then we get an unknown constant. And we can fill this in because they say at the origin, the rate of change of the function is 1. They're trying to talk in code here and make this look a little different. At the origin would mean when x equals 0. The rate of change of the function would mean its slope or its first derivative equals 1. So this has to equal 1 when x goes to 0. 1 equals 1/2 of 0 squared minus 0 plus c. c is 1. So our velocity, our first derivative, is 1/2 x squared minus x plus 1. Good. Not the finished answer, but something we needed. There's our acceleration. There's our velocity. The position of the original function is the antiderivative of this. So s is going to be integral all that stuff, which comes out to, let's see, x goes up to third power, divide by 3, so we get 1/6. X goes up to 2, and then divide by 2, or the power of x goes up to 2, and then divide by 2. The antiderivative of 1 is x, and then we get a constant again. So this is our position, except we don't know the c value yet, and we can get it because they tell us we will go through the point 1, 2. Now, they've been nice up to this point, and they've always been giving us 0, something, which made the substitution kind of easy. But this time, it's a little more work. Now they're saying when x is 1, the position, or I guess it's y. I shouldn't be using s because this is more about an equation than it is about a position function. Y should come out to 2. So I should be calling that y. I got used to equations of motion, which this kind of isn't. So y equals 1/6 of 1 cubed minus 1/2 of 1 squared plus 1 plus c. That gives us 2 equals 1/6 minus 1/2 plus 1 plus c. I need to create a little space. Okay. I don't want this to be all fractions, so I'm going to multiply the whole thing by the common denominator, 6. 2 times 6, 1/6 times 6, 1/2 times 6, 1 times 6, and c times 6. So if we clean this up, we have 1 minus 3 is -2, plus 6 is 4. Subtract that to the other side, we get 8 equals 6c. And that tells us, c is 8/6, which is 4/3. So that's our last constant, and our function, y, has to be, where did I put it? 1/6 x cubed, I'm just recopying all this, minus 1/2 x squared plus x plus the constant, and we know what it is now. It's 4/3.